Hi, I'm Joanna S. Lucas from PHY124 and this is for my subject, Physics for Engineers.
Hi, I am Joanna S. Lucas from PHY124 and this video is for my subject, Physics for Engineers. In this video, I will discuss how we can solve a problem that is related to freely falling bodies. Of course, by solving a problem. So, our problem is a volcano shoots out lava bomb from its summit. A man observing the eruption uses a stopwatch to time the flight of particular lava bomb that is projected straight upward. If the time for the bomb to rise and fall back to its launch height is 4.75 seconds and its acceleration is 1.81 meter per second squared downward, what is its initial speed? So, before answering it, we will draw our problem first for us to analyze it easily. Here is the volcano and its lava bomb and landed to where it launched. So, here our initial y or where the lava starts and the final y where it ends. After we draw it, we will identify the given for us to know the formula we can use. As I said, we have initial and final y, but it is both 0. Since our initial is 0 and the lava landed at is where it launched, so our final y is equal to initial y. So that's why it is both 0. We also have time according to the problem. The time for the launch, the time for the bomb to rise and fall back to its launch height is 4.75 seconds. So our time is 4.75 seconds and obviously our acceleration is 9.81 meter per second square from the gravity's value. Now that we know all the given, we can now choose the equation that is applicable in this problem. So, analyzing it, we will see that it is applicable on equation number 4, where final y is equal to initial y plus initial velocity
Times
plus
t.
1/2 times gravity times squared. Now, we can cancel initial and final position since it is both 0. We only have now, so since we will change it, it is already 0, we will cancel it. So, our equation now is 0 equals initial velocity
Times t
plus 1/2 times gravity times squared. So, since we need the initial speed, we will move this 1/2 times g times t squared at the other side of the equation for us to have an equation for initial speed. So, 1/2 or it will be negative 1/2 times g times t squared is equal to b sub o times t. So, since we just need the initial speed, we will cancel the t or the time at the side of the initial speed. So, let's divide it into t for us to cancel it. So, b sub o t over t and negative 1/2 times g times t squared is over t. So, let's cancel the t. So, our equation now will be b sub o is equal to negative 1/2 times g times t.
Since we already know what is the equation for initial velocity, we can now substitute our given. So, velocity or initial velocity is equal to negative 1/2 times the gravity. Since it is up or upward, our gravity is negative. So it will be negative 9.81 meter per second squared times our time, which is 4.75 seconds. Let's cancel the seconds since they both have seconds here. So cancel the seconds, and now we will have only initial velocity is equal to negative 1/2 times negative 9.81 meter per second times 4.75. So calculating it, our initial speed will be 23.3 meter per second. So our answer in this problem is 23.3 meter per second. So that is how we can solve a problem that is about free falling. So that's all. Thank you for watching.